Okay, so I'll be following along the second handout, which is making your T-Rex jump. The first step of this, of course, is that we have to make the T-Rex class. So let's do this. Let's copy the cactus class. So I'm here in my left-hand package explorer. I'm going to copy and paste. I'm going to call this T-Rex. And then open T-Rex. And then I'm going to replace I'm going to delete the things that I don't think a T-Rex should have. All right, so does T-Rex need an X and Y coordinate? I think yes, because it has to display itself. It needs a speed, but I'm going to call it Y speed because it moves up and down and not left and right. It will definitely need an image for itself, and probably more than one image, but let's keep one for now. And it will need the screen to display itself. Cool. We probably don't want it to have a starting speed, so let's delete this and have the starting speed just be 0. So this dot y speed is 0. And everything else seems okay, except I don't want the cactus anymore. Now let's go to the assets. And let's do TRex running 1, maybe. So T underscore Rex underscore running 1.png. All right. Draw seems okay. Move left. Let's delete move left because we don't want to do that anymore. Get width is okay to leave there. I mean, it's not clear if we need it, but it's not hurting anything. Is off screen we probably don't care about. And then reset position we probably don't care about. Okay, before we add the unique T-Rex methods, let's actually make sure we can create one and draw it. So let's put it over here, and then inside game, I'll make a T-Rex object. T-Rex. And then we'll create it in the constructor. So T-Rex equals new T-Rex. And the inputs are, let's see, a graphics window and then an XY coordinate. So the graphics window will be this, and the XY coordinate, let's make it be 50 and 150. And not lowercase t, because lowercase t is the name of the variable. Uppercase t is the name of the data type. Okay. And now I think the only thing we want to do is up here. Here I'm going to add a comment saying do cactus operations, and then here I'm going to say do T-Rex things. All right, so T-Rex.draw. And now let's run it and make sure we can see the T-Rex. All right, there it is. Cool. Let's start the cacti a little bit further away from ourselves. Let's make this like 400 and 500. Okay, yeah, that's a little better. Okay, and let's make them move a little bit faster. Okay, I like it. Let's just remember a few things about how to create movement. So just like we moved left and right by adding or subtracting from the x coordinate, to move up or down, we add or subtract from the y coordinate. So if you have a particular speed, if I say y equals y minus y speed, that's going to move me, let's see, which direction? So let's see if y speed is like 2, then I'm subtracting from my y coordinate, so the y coordinate is getting smaller. So that means it would be moving up, because 0 is at the top of the screen, which is confusing. So again, let's imagine like y is 500, y speed is 2, so I'm subtracting 2 every single time from my y coordinate. So the y values are getting smaller, which means my object is moving up. Okay, what about gravity? So movement is a change in the position. Gravity is something that accelerates you. So gravity is a change in your speed. Because if you imagine that you're moving, but your speed isn't changing, you're just moving at a constant speed and you're not accelerating. So that's what acceleration means. Acceleration means that your speed is increasing. So here I'm saying let's subtract whatever the amount of gravity is from the y speed. Why subtract? I mean, it's sort of arbitrary because it depends on whether this is positive or negative. But let's do this. Let's add gravity into the y speed, and then we'll have y speed subtract from the y coordinate. A good value to use for gravity would be something like 0.4. We don't want gravity to be really large. But the problem is, once you make it 0.4, now y speed can't be an int anymore, and your y coordinate can't be an int anymore. So you'll have to change them all to be float. Okay, last thing is, how do we jump? So the way that we start a jump is by giving ourselves an upward y speed. So if we just set the y speed to 10, now all of a sudden we have a kick of upward velocity. That won't actually have us continue through the jump. So a jump actually, even though you think about a jump as being kind of a single operation, from the perspective of the code, the jump is going to happen in 2 steps. We're going to have like a start jump method, which gives the T-Rex an upward speed, and that's what this will do. But then we'll have a second method called update position, which will let gravity do its work and slow the jumping T-Rex down until it hits the top of its jump, and then it will turn around and change directions, and then it will eventually hit the ground again. So there's 2 separate methods. So I'll leave it to you to go ahead and fill in these methods. I've named them start jump and update position. Start jump, I thought it might be nice to take an input that's the upward speed that we want the T-Rex to jump with. So that's sort of like the jump strength, if you will. And then update position should move the T-Rex according to its speed and change the speed according to gravity. So you're going to be changing both the y coordinate and the y speed. Right now I'm just going to put print statements inside there. And the reason why is because I want to see if they're running at the correct times when I change the game class. So I want T-Rex to update its position all the time. Well, maybe. Maybe I only want it to update its position when it's in the air, and then once it's hit the ground, we wait for the user to hit the jump key again. But for now, let's have it update its position all the time. The last part is remembering how do you actually have the game respond to key presses. So at the end of the draw method, way down here where the brace closes, underneath that, let's add a new method that's a built-in one called key released. And we'll say if the key equals, and then notice there's a space in here, it's not just quotes. So if the key was the space key, then let's make the T-Rex jump. And we'll make the T-Rex jump by running its jump method. So T-Rex dot, what do I call it, start jump. And I guess we'll give it 10 here. All right, so let's run the game. And it's not going to jump, but every time I hit the space key, of course, you see nothing happens. Well, that's not what we wanted to happen. Oh, okay, cool. So it is working. So I just opened my console. You see that it's updating position all the time because right here I told the T-Rex to update its position. When I hit the space bar, you can see scrolling past update position, all in caps there. Definitely when you do it, you can do it. Sorry, not update position, starting jump. So I can see that these things are running at the times I want. Now you just need to actually fill in the inside so that they change your coordinates the way that you want. All right, so I've made those changes. Part of what I did was add this gravity up here, which is negative 0.4. The F means float, because as you can see, it is a float. I also needed to change my X and Y speed to floats. And when I run it, I just immediately fall through the floor. Cool. But if you'll notice, I can still hit the space bar to jump. And now we've created some kind of weird T-Rex Flappy Bird. So it seems like there's a bug. We need the T-Rex to actually stop when he's on the ground. And we need to make sure that the T-Rex can't jump while he's in the air the way that I have right now. So let's fix those last 2 parts. So we'll need to be able to ask, is the T-Rex on the ground? And if we have a method that answers that question, then we can say if the T-Rex is not on the ground, then don't run update position. Oh no, I'm sorry, the other way around. If the T-Rex is not on the ground, that's when we want to run update position. So like up here, if T-Rex dot is on ground equals false, that's when we run update position. Because remember, this is what's making us fall using gravity. So if I'm on the ground, I don't want to fall using gravity. So that should fix that problem. And you can use the same method to answer whether or not we should jump. Over here, just pressing the space key isn't enough. We want to say, like, if the T-Rex is on the ground, then we can jump. So if T-Rex.isOnGround equals true, then we can jump. So everything is fixed as soon as we write the isOnGround method. To write the isOnGround method, we need to ask, is the bottom coordinate of the T-Rex larger than, I think 200 is where we drew the ground. That's might be false. Here's the line is at 200. That's a bit of a magic number, and we should probably change it. But the problem is the xy coordinates of the T-Rex, though the y coordinate of the T-Rex is the top of the T-Rex. So I recommend do something similar to what we did with getWidth, only call it getHeight, and then fill in this part. All right, so I've made those changes, and here I'm pressing space and nothing is happening. So let's think, why is nothing happening? I know why. So I'm on the ground. I hit the space bar. I check, am I on the ground? The answer is yes. So I start the jump. And starting the jump sets my y speed. But the problem is when I don't actually move until I do update position. So here I say, am I on the ground? And the answer is yes. And so I don't update the position with my new jumping speed. So you can solve this however you want. I think one thing to do is start jump. You could change it so that you actually change your y coordinate, like do the first part of the jump. A different thing you could do is here you could, well, maybe that's the best thing to do. Yeah, I would probably do that.